Okay, so here are the solutions to our quiz. And the first two we are proving, we are verifying an identity. And both number one and number two, they both have two terms that somehow have to become one term. So I'm going to approach those the same way. I'm going to convert them to fractions, get a common denominator, and then add those two denominators. So for number one, I got 1 over 1 minus cosine of beta plus 1 over 1 plus cosine of beta. And to get a common denominator, I'm going to multiply this by 1 minus cosine beta over 1 minus cosine beta. And this one, 1 plus cosine beta over 1 plus cosine beta. The fractions on the left, well, the numerator will become 1 plus cosine beta over 1 minus cosine squared. Because if you multiply two conjugates, you will get a difference of squares. On the right, you get 1 minus cosine beta when you multiply the two numerators, and the denominator again becomes 1 minus cosine squared. Those two fractions add up to become one fraction. The denominator stays the same, but the numerator, the cosine plus negative cosine, those cancel out, and 1 plus 1 is 2. Well, how am I going to get 2 times the cosecant squared? Well, 1 minus cosine squared is the same thing as sine squared. And if you divide by sine squared, that's the same thing as multiplying by cosecant squared. So that is the proof. For number two, I'll first convert tangent squared to sine squared over cosine squared. And you're minusing sine squared, which is the same thing as sine squared over 1. I'm going to get both of those fractions to be the same, so it's cosine squared over cosine squared. You know, what's in red right there equals 1, so I'm not changing the value of anything. The first fraction minus this fraction. And that becomes one fraction. The denominator is cosine squared. The numerator is sine squared minus sine squared times cosine squared. But then now what? I need somehow that to equal tangent squared times sine squared. What can I do? Well, the numerator, those two terms in the numerator, they both have a sine squared in common. So I can factor that out. And at this point, we should be able to see that we're just about done. Because what do I have? I've got sine squared divided by cosine squared. That equals tangent squared. And that's being multiplied by 1 minus cosine squared. That equals sine squared. So I know I'm on the right path. I just have to express it. I just have to write it out. So I'm going to break up that big fraction into one factor times the other factor, 1 minus cosine squared over 1. And sine squared over cosine squared is tangent squared. 1 minus cosine squared is sine squared, and sine squared divided by 1 is just sine squared. So that is that proof. Number 3 was the least significant out of the first 3. You have to recognize that this is we're using a difference formula. I saw too many students write this out. This is never true. It looks like you cannot distribute the letters COS. There is a formula for the difference of two angles with a cosine. It will be the cosine of the first angle times the cosine of the second angle, plus the sine of the first angle times the sine of the second angle. And I somehow need to make all of that equal just the sine of A. How do I do that? Well, now you evaluate. We don't know what cosine A is, but I know what the cosine of pi over 2 is. It is 0. Sine of A, I don't know. But the sine of pi over 2 is 1. Cosine of A times 0 is 0. sine of A times 1 is sine of A, and 0 plus sine of A is just sine of A. Number 4, you are using the difference formula for tangent. So the tangent of 11 pi over 12 is the same thing as the tangent of 5 pi over 4 minus pi over 3. And looking at the difference formula, it is the tangent of that first angle. Some people are just writing down the angle. Some people are just writing down that. That's not right. It's the tangent of that first angle minus the tangent of the second angle divided by 1 plus the product of those two. Well, the tangent of pi over 4 is 1. The tangent of pi over 3 is rad 3. So you get this value. That value, that last fraction, is the tangent of 11 pi over 12. But we want to get rid of that radical, so I'm going to multiply by the conjugate. And in the numerator, I have 1 minus rad 3 minus rad 3 plus rad 9. In the denominator, I end up with negative 2. I end up with a square minus a square. 1 squared minus rad 3 squared. Because I multiply, that happens when you multiply two conjugates. And now I've got 4 minus 2 rad 3 over negative 2, which simplifies to negative 2 plus rad 3. For number 5, we had to find the sine of A minus B. According to the formula, that equals the sine of A times the cosine of B minus the cosine of A times the sine of B. So I have to find all 4 of those values. Let's start with angle A. A is in quadrant 4, so I'm going to draw a rectangle in quadrant 4, and I know that the cosine of A is rad 10 over 7. Cosine is adjacent over hypotenuse. So to find the other leg, I do Pythagorean theorem, and I discover that the leg is rad 39, but since I'm in the 4th quadrant, that means the y value is negative, so down rad 39. And this is angle A. Angle B is in quadrant 1, so I draw a triangle in quadrant 1. And what do I know about B? Well, I know the tangent is 7/2. Tangent is opposite over adjacent. And then to find the hypotenuse, I again do the Pythagorean theorem, and I finally get the square root of 53 is the hypotenuse. All right, so I've got a lot of information about angle A, I've got a lot of information about angle B, and now I'm ready to go back to this. What is the sine of A? It is negative rad 39 over 7. What is the cosine of B? Positive 2 over rad 53. The cosine of A is positive rad 10 over 7. The sine of B is positive 7 over rad 53. And then I simplify it. The numerator is negative 2 rad 39 over 7 rad 53 minus 7 rad 10 over 7 rad 53. And I got 2 fractions that have the same denominator, so they can combine into 1 fraction. And that's a long way towards simplifying, but there's one problem. I've got a radical in the denominator, so I'm going to multiply by just rad 53 over rad 53. You don't need a conjugate because this is not a binomial. You don't need 7 rad 53 over 7 rad 53. That causes you more work. There's nothing wrong with the 7, so leave that alone. If you decide to add the 7, then that causes you more work because you're going to have to cancel the 7 at a later step. So just focus on the problem. The problem is rad 53, so I just have to multiply by rad 53 over rad 53. And that gives me negative 2, I think think this is 2067 minus 7 rad 530 over 371. And that would be the final answer for number 5.